Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the earlier videos of geometry where I have covered what are triangles and its properties, geometric centers of triangles, similar and congruent triangles, quadrilaterals like parallelogram, rhombus, trapezium, etc. and so on. In case if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to start with circles. So let us begin with this video. I have divided the circle topic in three parts. In the first part, we'd be seeing what is a circle, a chord, what is the circumference and area of a circle. After that, we'd be seeing what is an arc of a circle, how we can find the length of an arc of a circle, what is a sector, segment, and how we can find the area of a sector and segment and so on. Post that, we'd be seeing what is an inscribed angle theorem and its corollaries. So this is what we are going to do in the first part of the circle videos. In the second part, we'd be starting with what is a tangent and secant, and some important theorems on tangents and secants. After that, we'd be seeing what is an alternate segment theorem. Post that, we'd be seeing the number of common tangents to two circles, what is a direct transverse common tangent, and how we can find the length of direct and transverse common tangent. After that, we'd be seeing what is a cyclic quadrilateral and its properties. So this is what we'd be seeing in part 2 of the circle videos. And finally, in the third part, we'd be seeing some problems on circles based on the above concepts. So let us begin with the first part today. A circle can be defined as the locus or the path of a point which are equidistant from a fixed point. This fixed point is called as the center of the circle, and the boundary of the circle is called as the circumference of the circle. Now, any line segment joining any point on the circumference of the circle with the center of the circle is called as the radius of the circle. So this line which joins a point on the circumference of the circle with the center of the circle can be termed as the radius of the circle. Any line segment joining any two points on the circumference of the circle is termed as the chord of the circle. So here this line is joining two points on the circumference of the circle can be termed as the chord of the circle. Any chord of the circle which passes through the center of the circle is called as the diameter of the circle. So this line segment would be the diameter of the circle as this passes through the center of the circle. Now, if we denote the length of the radius by small r, in that case, the line segment joining these 2 points will also be of the length of r, as it would be the radius of the circle. In a similar way, the line segment joining this center of the circle with this point on the circumference of the circle will also be the radius of the circle. So this length will also be small r. But we know that this total length is the diameter of the circle. So we can say that the diameter of the circle would be r plus r, that is 2r. So the diameter of a circle would be 2 times the radius of the circle. Now for any circle, the ratio of the length of the circumference of the circle to the diameter of the circle is constant and is denoted by pi, where the approximate value of pi is 22/7 or 3.14. So from this, we can say that the circumference of a circle C would be d times pi, and we know that the length of the diameter is twice the length of the radius. So from this we can say that the circumference of the circle would be 2 pi into r. Also, the area of a circle is given by pi into radius square. So, for any circle, the length of the diameter is twice the length of the radius. The circumference of the circle is given by 2 pi r, and the area of a circle is given by pi into r square, where the approximate value of pi is 22 by 7 or 3.14. Now, let us see what is an arc of a circle. Here, I have drawn a circle with center OC. I have considered 2 points on the circumference of the circle such that these 2 points divide the circle into 2 parts. This is the smaller part and this is the bigger part. These parts are called as the arc of the circle. Since this is the smaller arc, so this is called as the minor arc of the circle. And since this is the bigger arc, this is called as the major arc of the circle. So any 2 points on the circumference of the circle divide the circle into 2 parts, and these parts are called as the arc of the circle. The smaller part is called as the minor arc of the circle, and the bigger part is called as the major arc of the circle. Now let us denote these 2 points by A and B, and let us join these 2 points A and B to the center of the circle to form a central angle AOB. Let us denote this angle by theta. So theta is a central angle formed by the minor arc AB. Now we can find the length of this minor arc AB. We know the circumference of the circle is given by 2 pi r when the central angle is the complete angle, that is 360 degree. So we can say that when the central angle is 360 degree, we get the circumference of the circle, which is given by 2 pi r. So when the central angle is theta degree, in that case, we'd be getting the length of the minor arc AB, which would be theta upon 360 times of 2 pi r. So if we know the central angle theta and radius r of the circle, in that case, we'd be able to find the length of the arc of the circle. In a similar way, we'd be able to find the area of this sector formed by the arc AB. We know the area of a circle is pi r square when the central angle is 360 degree. So when the central angle is theta degree, in that case, the area of the sector formed by the arc AB can be written as theta upon 360 into pi r square. So if we know the central angle theta and the radius of the circle, we'd be able to find the area of a sector formed by any arc on the circle. Now let us join these 2 points A and B to form a chord AB of this circle. The area formed between this arc and this chord is called as the segment of the circle. So this green shaded area represents the segment of the circle formed between this arc and the chord AB of the circle. We can also find the area of this segment simply by subtracting the area of the triangle OAB from the area of the sector OAB. So the area of this shaded segment can be written as area of the sector OAB minus the area of the triangle OAB. We know the area of sector OAB can be written as theta upon 360 into pi r square, and the area of the triangle OAB can be found out simply by using the formula for the area of a triangle, which is given by half into product of two sides into sine of the angle between them. Here, the two sides OA and OB are the radius of the circle, and the angle between them is theta. So the area of triangle OAB can be written as half into R, that is R square, into sine of the angle between them, that is sine of theta. So the area of the shaded segment can be found out simply by using this formula, which is theta upon 360 into pi r square minus half into R square into sine theta. So the length of an arc with central angle theta is given by theta upon 360 into 2 pi r. The area of a sector with central angle theta is given by theta upon 360 into pi r square, and the area of a segment between an arc and a chord is given by theta upon 360 into pi r square minus half into R square into sine theta. Now, there are some theorem on chords which we need to remember. The first is the perpendicular distance from the center to a chord bisects the chord. Say we have a circle with center O and there is a chord AB, and a perpendicular has been drawn from the center on the chord AB at point P, say. So this theorem states that if OP is perpendicular to AB, in that case AP would be equal to PB. That is, the perpendicular distance from the center to a chord will bisect the chord. The converse of this theorem is also true. That is, a line joining the center of a circle to the midpoint of a chord would be perpendicular to the chord. That is, if AP is equal to PB, then OP would be perpendicular to AB. The second theorem states that equal chords of a circle are equidistant from the center. Say we have a circle with center O such that AB and CD are two equal chords. Then the distance of these two chords from the center of the circle would be equal. That is, if AB is equal to CD, in that case OP would be equal to OQ. The converse of this theorem is also true. That is, if two chords are equidistant from the center, then the two chords would be equal in length. That is, if OQ is equal to OP, then CD would be equal to AB. Now let us see the third theorem on chords. The third theorem states that equal chords of a circle subtend equal angles at the center. Say we have a circle with center O such that the chords AB and CD are equal in length. Then the angle formed by these two chords at the center would be equal. So if AB is equal to CD, then the angle AOB would be equal to angle COD. The converse of this theorem is also true. That is, chords which subtend the same angle at the center are equal in length. So if angle AOB is equal to angle COD, then the length of the chord AB would be equal to the length of the chord CD. So the perpendicular distance from the center to a chord will bisect the chord. Equal chords of a circle are equidistant from the center, and equal chords of a circle subtend equal angles at the center. Well, here I have not shown the proof for these three theorems, but if you guys are interested, you can prove this simply by using the concept of congruent triangles. But my suggestion would be to simply remember these theorems, which would be sufficient. Now let us see what is inscribed angle theorem. Inscribed angle theorem states that angle subtended by an arc at the center is twice the angle subtended by the same arc at the circumference. So if the arc AB subtends an angle theta at the circumference, then the angle subtended by this arc AB at the center would be twice of this angle, that is 2 theta. And this is inscribed angle theorem. In a similar way, if the arc AB forms an angle at different point on the circumference, then this angle will also be theta. As this arc AB subtends an angle of 2 theta at the center, so the angle formed by this arc AB at the circumference will be half of this angle. So this would be theta. So from this, we can say that angles formed by the same arc on the circumference would be congruent. That is, if the arc AB forms an angle theta at point P, then it will form the same angle theta at point Q or any other point on the circumference. Also, from the inscribed angle theorem, we can say that angle inscribed in a semicircle is always a right angle. To see that, let us consider a circle again with center O, and AB is the diameter of the circle and P is a point on the circumference of the circle. I have joined the point A and P and the point B and P. We know this is a straight angle that is 180 degree. And from the inscribed angle theorem, we know that angle at the circumference would be half of the angle at the center formed by the same arc. So here AB can be considered as an arc, and if this angle is 180 degree, so this angle would be 90 degree. So angle inscribed in a semicircle is always a right angle. So angle subtended by an arc at the center is twice the angle subtended by the same arc at the circumference, and this is known as inscribed angle theorem. And from this, we have derived that angles formed by the same arc on the circumference are congruent, and angles inscribed in a semicircle is always a right angle. So that's it for today's video, in which we have seen what are chords and arc of a circle, how we can find the area of a sector and segment, some important theorem on chords and inscribed angle theorem. And in the next video, we are going to see what are tangents and secants, along with some important theorems on tangents and secants, alternate segment theorem, what is direct common tangent and transverse common tangent, cyclic quadrilateral, and so on. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I will see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.